When I taught undergraduate natural language processing in fall 2022, when I introduced the course, I needed to explain to the students taking the class why anybody would care about natural language processing. I had to explain that although we had self-driving cars and superhuman chess and Go players, chatbots were obviously worse at talking to you than a 5-year-old. Well, guess what? Thanks to ChatGPT, which came out while I was teaching the course, I didn't have to do that anymore. ChatGPT is everywhere and has at least the communicative ability of a 5-year-old on a good day. And guess what? ChatGPT also gives a new framework for explaining about what my undergraduate natural language processing course is about. In many ways, my undergraduate NLP course is the story of what makes ChatGPT possible, and what will make the next advance after ChatGPT possible. Now, I'm going to list off a bunch of stuff. I'm not going to go into the details here. We have full lectures on all of those things, links in the description. So let's start off by just talking about what ChatGPT is. As we define what ChatGPT is, we'll see what goes into it. You could define ChatGPT as an autoregressive neural transformer language model trained with human feedback. Now that's a lot of fancy words. Let's drill down into some of these one at a time. First, let's focus on the neural bit here. There are two things that made the neural revolution possible and allowed us to create modern neural architectures: nonlinearities and distributed representations. Nonlinearities are when you have some aspect of a system where the input goes through a nonlinear function. And I've drawn a couple here, like sigmoid or ReLU. So that's the first ingredient of ChatGPT. Early in the class, we'll go through how to derive updates for logistic regression, which is probably the simplest nonlinear neural method that you could implement. We'll learn how the properties of these activation functions made many of the advances that we saw in many domains possible, not just in natural language processing, but also for things like computer vision. Ingredient 2, distributed representations. We'll next talk about the inputs to nonlinear functions and how those inputs can encode the meaning of a word. Having a vector encode what a word is about. These distributed representations are a vector space, where words live in that vector space such that similar words are close to each other. Their dot product is big. We'll learn how to build these sorts of representations from large amounts of text that can then encode the meaning and the knowledge in that text. Ingredient 3, language models. In addition to the actual mathematical functions involved, there's also what the models are doing. At a basic level, they're just filling in the blanks in, say, a document, predicting what the next word is going to be. We'll talk about the details of how you actually do this and how to know if you're doing it well, a task called language modeling. Ingredient 4 is transformers. No, not the Hasbro Takara Tomy collaboration, nor the device that changes voltages. Rather, it's a specific architecture that puts together a lot of the pieces that we talked about before. It builds on the distributed representations and nonlinearities and puts them together into a large model, frankly more like Voltron than Optimus Prime, that revolutionized natural language processing in the last 10 years. We'll talk about the specifics of this model and how it works, and what are some of its drawbacks. Ingredient number 5, human feedback. Just predicting the next word, the language modeling task that we just talked about, isn't enough. We'll learn how having a human in the loop, taking a look at the output of the models, and getting the models to say the right thing, can make these better. How it works, and how it made ChatGPT possible, so that it could use the information encoded in large text collections to actually do something useful. And that's how we'll end the class, talking about the applications of these models to understanding the structure of language, doing machine translation, and my particular favorite, question answering. And we'll have some fun playing trivia games against these computers. This is just one video from a course that I'm teaching. If you want to get the whole context, check out the course webpage, linked below. There you can find all of the videos in the right order. YouTube likes to show you older videos out of order, homeworks, exercises, and recommended readings. And if you want to help other people find videos like this, please be sure to like and subscribe to provide a big gradient to the algorithm.